Alright, what's up everybody? So today we're getting into probability and regarding compound events, and then the second slide will be independent and dependent events. Now your homework is also the outline notes that I'm working on right now, so if you haven't printed that out yet, pause this video, go print them out, and then follow along as we go through this, okay? So compound events, alright? Compound events are two or more events put together to make one event. It's called the union or intersection of two events. You will see the word or whenever we have a compound event. And or means we are going to add the probabilities together. Okay, so remember, probability is desired outcome divided by the total number of outcomes, right? And so we've been talking about total number of outcomes when we've been doing permutation, combination, and the fundamental counting principle, okay? So first thing is disjoint events, all right? So disjoint events are events that cannot happen at the exact same time, right? And so we're going to be adding those two things together. So notice that each one of these is having two things going on, right? So an example would be, what are the odds of choosing a 3 or a face card out of a deck of cards, right? And so the reason why this is disjoint is because there's no what we call overlap. There's no 3s that are also face cards. And so the probability of this would be, we know that there's 52 total cards, right? And there are 4 3s in a deck of cards. So the odds of picking a 3 are 4 out of 52. And then a face card, there are 4 face cards per suit. So there's 16 face cards total. There's the Jack, Queen, King, and I usually count an ace as a face card as well. So there's the Jack, Queen, King, and the ace. Jack, Queen, King, ace. And there's a set of those for each different suit. And since we have 4 suits, that means there are 16 total face cards in a deck, right? So the probability of getting a 3 is 4 out of 52. The probability of getting a face card is 16 out of 52. And so the probability of getting a 3 or a face card would be 4 out of 52 plus 16 out of 52 for a total of 20 out of 52. And then obviously we need to reduce that fraction. So that if we reduce by 4, so it goes into 4 goes into 25 times, and it goes into 52 13 times. So the odds of getting a 3 or a face card would be 5/13. So again, this is what we call disjoint, meaning there is no overlap between the two events, okay? The other one we call is overlapping events, right? So the events can happen at the same time. We're still going to be adding the probabilities together. However, we need to subtract the probability of the overlapping event. Okay, so that's where the little bit of a difference comes in here. And so an example of that would be choosing a black card or a 3, right? So we know that for black cards, there are 26 total black cards in a deck. So the odds of getting a black card is 26 out of 52. We already said that there are 4 3s in a deck, so we know the odds of that is 4 out of 52. But then that overlap, that a card that's black and also a 3, there's 2 of those in our deck. So the odds of getting a black 3 is 2 out of 52. So we take our individual odds that we're trying to get, 26 out of 52, a black card, 4 out of 52, a 3, we add those together, but then we need to subtract the overlapping probability, which would be 2 out of 52, or the black 3, right? So eventually this becomes 30 out of 52, subtracting 2 out of 52, which gets us to 28 out of 52. Once again, reducing that by 4. Okay, so 4 goes into 28 7 times, and it goes into 52 13 times. So we have a 7/13 chance of getting a black card or a 3 when drawing from a deck of cards. Okay? So I'm going to do number 1 and number 4 with you right now, and then your homework is to finish the rest of this page. So it says there are 7 red, 8 green, and 6 blue marbles in a bag. Kate is going to select 1 marble at random. What is the probability that she will select a green or a blue marble? Okay, so first thing here is notice that it's or, right? So this is a compound event. But also notice that there is no overlap, right? There's no marbles that are green and blue. There's no marbles that are red and green. So first things first is what is the total number of outcomes? Well, there's 7 red, 8 green, and 6 blue. So there's a total of 21 marbles. Okay? So we're asking what is the probability of selecting a green or a blue? So the odds of selecting a green is 8 out of 21, our desired outcome over the possible numbers of outcomes, which is 21. The odds of selecting a blue is 6 out of 21. Okay. Now all we have to do is add those odds together. 8 plus 6 is 14. 14 out of 21, or a 2/3 chance of getting a blue or a green marble. Easy, right? Easy. Let's jump down to number 4. In Mrs. Carr's math class, 9 of the 14 girls say they like math, and 7 of the 16 boys said they like math. If Miss Carr randomly selects a student, what is the probability she chooses a girl or someone who likes math? Okay, so once again, this is or, right? So we know we're going to be adding our odds together. But now we have overlap because the odds of picking a girl, right? Actually, let's do this first. Let's think what our total. So we have 14 girls, 16 boys. That means we have 30 total students. Okay? And we know that we have 14 girls. So the odds of picking a girl is 14 out of 30, right? But then for someone who likes math, it could also be a girl and they could like math. So that's where this is going to be an overlap problem. But the odds of picking someone who likes math is 9 girls, 7 boys, for a total of 16. So 16 out of 30. So that would be our odds if there was no overlap. 14 out of 30 plus 16 out of 30. The 14 out of 30 is the number of girls. The 16 out of 30 is representing the number of people that like math. However, we have to subtract the overlap. So how many girls like math? That would be this number right here. Okay? So we have to subtract the overlapping amount, which would be 9 of the girls like math, because that category is what we're searching for. So we need to subtract that amount. 14 plus 16. Okay. Whoa. My fault. I messed up. Nope, that's right. 14 plus, because we got the 9 plus 70 is 16. So 14 plus 16 is 30 out of 30, right? But then we have to subtract the 9 out of 30, which gets us to 21 out of 30. Go ahead and reduce this by 3. 7/10. So the odds of picking a girl or someone that likes math is 7 out of 10. Okay? And so that is the compound events using or. Let's now look at independent and dependent events. Okay? So now with independent and dependent, we see the word and, because you're finding the probability of more than one event occurring, right? So when there is more than one event occurring, you are going to multiply the probabilities together. Okay? Luckily for us, we don't have to worry about any overlap so much right now. Okay? So it says you have independent and dependent events. So independent events, they're not related, okay? As in, and also if you're dealing with pulling something out of a bag, this is like you're replacing it, because independent means is whatever happened on the first event, it does not affect the second event. So flipping a coin, rolling dice, whatever you get when you flip the first coin or you roll the first dice has no effect on the second time you do it. Okay? The next option is dependent, meaning the first event affects the odds of the second event. So imagine you're picking things out of a bag, and say we have 10 tokens in a bag and I pick one token. Now for my next one, there's only 9 tokens left, so I'm not putting it back. So my second odds are affected by what happened in the first time around. Okay? And so what we do here, the number of fractions being multiplied together should be the same number of the times you are choosing, right? So if I'm pulling out of a bag 3 times, I should be multiplying 3 fractions together. If I'm rolling a dice 4 times, I should be multiplying 4 fractions together. So out of a class of 20 students, your teacher chooses students at random to present their projects. What is the probability that she chooses you first and then chooses Kim second? Okay, well, we have 20 total students. Okay, now the odds that she picks me is 1 out of 20 because I'm the only one in my class that's me, right? But now that she's picked me, the odds of her picking Kim, we only have 1 Kim in our class, is now 1 out of 19 because I've already been picked. I'm not in the pool to be picked now, right? I'm not an option anymore. So all we have to do now is multiply these together. 1 times 1 is 1. 20 times 19 is 380. So the odds of me getting picked first and Kim getting picked second is 1 out of 380. Okay? You flip a coin. What is the probability that shows heads on the first flip and tails on the second flip? Well, the odds of getting heads is 1/2. The odds of getting tails is also 1/2. The results of the first do not affect the results of the second, so we multiply them together. 1/4. Okay? I'm going to let you guys give this a try. I don't want the video to be too long. Please let me know if you have any questions.